Hello, this is Integrated 3, Unit 1, Lesson 1, Brutus Bites Back. In the Jumpstart, when they ask you which one doesn't belong, any of these four can be the answer. You just have to give a reason why. We're going to skip that for this video and go right into the launch problem. It says a couple of years ago, Carlos and Clarita started earning money by taking care of pets while the pet's owners are away. Due to their amazing mathematical analysis and their loving care of the cats and dogs they take in, Carlos and Clarita have made their business very successful. To keep the dogs fed, they must regularly buy Brutus Bites, the favorite food of all the dogs. Carlos and Clarita have been searching for a new dog food supplier and have identified two possibilities. The Canine Catering Company, located in their town, sells 7 pounds of food for $5. Customers buy the food in bulk so they can purchase any amount. The amounts of food purchased often include fractions of a pound, such as 2.6 pounds or 3.9 pounds. Carlos thought about how much they would pay for a given amount of food, and he drew this graph. Make a table and write the equation of the function that Carlos graphed using D for dollars and P for pounds. So when we do a graph like this, the first variable that we put is on the x-axis, and that's called the independent variable. The y-axis has what we call the dependent variable. Now you can see by scanning along this line that 0, 0 is definitely a point on the line, and so is 7 and 5. So we'll record those two, 0, 0, and 7, 5. And now to come up with the equation, first of all, we can see that the y-intercept is 0. Now let's talk about slope. The slope is the change of the y, or the dependent variable. It's going up by 5 here, divided by the change in the independent variable. That's plus 7. So the slope is 5/7. That means we can write that dollars equals 5/7 pounds. And there's our equation. Now in number 2, Clarita's going to reverse that idea. And she creates this graph. Again, we have 0, 0 is clearly on the line, and 5/7 is clearly on the line. But now notice that the x-axis is dollars. So D first, and then pounds second. Dollars is now independent. Pounds is dependent. And that means we have 0, 0, and 5/7. Well, the change of the dependent variable is 7, and the change of the independent variable is 5. That makes this 7/5 slope with, again, the y-intercept is 0. So dollars is 7/5 times pounds. Now, comparing those two, it says write an equation that would be most easily answered by Carlos' graph, and write a question that would be easily answered by Clarita's graph. What's the difference between the two equations? Well, if you look at the difference right now, actually, you know what? I wrote this one backwards. Make a little correction here. That would be P for pounds first and D for dollars second. Yeah, so they're reversed. They're supposed to be reversed in the D's and the P's. And the fractions are upside down compared to each other. We call those reciprocals. Okay, so a question answered by Carlos' graph would be for a given number of pounds, how much does it cost? So you could say, for Carlos, how much does, say, 3 pounds cost? I'm just making up the number of pounds. And for Clarita, her equation is built to answer questions like, how many pounds for, let's say, $4. So the relationship between the two functions, number 4, is they are inverses. They are inverses. They undo each other. So they are undo functions. Now looking online, Carlos found a company that will sell 8 pounds of Brutus Bites for $6, plus a flat $5 shipping charge for each order. And the company advertises they'll sell any amount of food at the same price per pound. So let's model this relationship. Again, we're going to use a table and then go to the graph. So if you notice, we're for him, pounds is on the X, so pounds will lead us off, and dollars is on the Y. Now, it says you have a flat $5 shipping fee. That means no matter how much you purchase, you still got to pay $5. So in the crazy scenario where he doesn't purchase anything, he still would have to pay $5 to have that shipped. And then if we look at, let's see, $6 will get you, let's see, we'll sell 8 pounds of Brutus Bites for $6 plus this flat shipping fee. So if we were to jump to, let's see, 8 for the, well, let's go to 11 here. 6 plus 5 would be $11. So we've paid the $6, we've paid the shipping fee, and they're going to send us 8 pounds. That ought to be enough to figure out the slope, because the jump here is a jump of 6, and the jump here would be a jump of 8, and 6 divided by 8, if you think about it in terms of money, is 0.75. It's 3/4 or 75 cents. So that means that for every 1 pound, we're going to get, it's going to cost us 0.75. So because that was change of Y over change of X, that would be read as dollars per pound. Remember, pound is an LB. Dollars per pound. So if I wanted to go to, say, 1 pound, that would be $5.75, and so on. So his equation is, okay, the slope is 3/4 or 0.75 plus that flat $5 shipping fee. Now, what about her? Okay, now she's going to reverse all that. So what's going to happen is dollars will be the X and pounds will be the Y. And then let's see. So if she spends $5, they're not going to send her anything. And then she's got to spend up to $11 for them to send her 8 pounds of food, because it's $6 on top of the $5 shipping fee. So this one just changed by 8, and this one just changed by 6, and 8 over 6 reduces to 4/3. Now that would be pounds per dollar. 4/3 of a pound per dollar. Now, let's see if we can figure out what her equation would be. Now, do you remember when we were doing arithmetic sequences that when you start somewhere, so in this case, we started with 5, we would have to modify the x variable. So we have to do an x minus 5 or an n minus 5 or something like that. So in this case, we have to do the same thing. We have to do a d minus 5 to kind of calibrate it so that we're starting at 5 and not at 0. And then we throw in our slope here, and then that's what the pounds is equal to. So that when you put in $5, it comes out to 0 pounds. Oops, didn't mean to do that. There we go. Just wanted to put a box around this. Now, let's go back and look at those graphs real quick. So this first one here, remember we're at 0, 5, and then when we get all the way out to 11, we're at 8. So we're way up here. Another point along the way, sort of in the middle, would have been 4 and, let's see if we got that right. No, I got that backwards. We needed 8, 11. 8, 11 is not going to fit. So an in-between point would have been 4, 8. 4, 8, right here. And it keeps on going up from there. It's eventually headed toward 8, 11. Now this one, the second one, well, this has just got shifted to the right 5. And that one would have the point 11, 8 on it. We can get to there. 11, 8 would be right here. And there's a point in the middle you can get to, which would be 8, 4 right here. So her line is looking like this one. Again, what is the relationship between the functions? They are inverses. They undo each other. The inputs and the outputs have been changed. Now, how we write that in function notation is we would put a little -1 up here. And that means inverse. It does not mean a power. So the inverse of the dollars per pound would be the price. Actually, that wouldn't be an X, would it? That would be $1. And also you could write it the other way. The price per dollar is the inverse of dollars per pound. Not price, pounds, P for pounds. So that -1 is your symbol for an inverse function. All right, so if you notice in the table, what's going on is things are reversing. Instead of 5, 0, 11, 8, you have 0, 5, 8, 11. The slopes are reciprocals of each other, right? And actually, if we graphed these both at the same time, there is a reflection going on between these two graphs. In fact, they reflect across the line y equals x. So we'll look at that, of course, on Desmos in class. But for our takeaways, there's basically 3. Number 1, inputs, outputs reversed. Number 2, the slopes are reciprocals. And number 3, graphs reflect over y equals x. And I'll drop an image of that onto the video when I'm doing the editing. So notation for inverse functions, f to the -1 like this actually means the inverse. the inverse of f of x. We talked about independent, dependent variable. Independent is along the x, dependent is along the y. A point is an input-output pair. We talked about an inverse function. These have been linear functions. The rate of change, the slope, is always the change in the dependent variable divided by the change in the independent variable. So the change of y over the change of x, in other words. So make sure you read the lesson summary, and that's it for now. See you next time.